Line 22, 7B100, Twistor, Hilbert, space, vector, R, Spinor, Spinor Klein, Minkowski, formula, Wow Seti. There's the alien radio signal. And this is R, Spinor, Twistor theory, Hilbert, space, Spinor Klein, correspondence, Minkowski, space-time equations. And formulas found in Wow 22, alien radio signal data for UFO core engine component ideas. Okay. In the previous video, November 23rd, I really have to fix this, is line 22, 7B99, cross-reference line 17, T2B, alien message, wow, signal, math, equations, data. I think I changed it. Seti. Yeah, I did too. Put the word Seti there. Okay. My thoughts. Line 22, 7B97, Z84A. Elastic OH atoms, molecules, collisions, ultra-cold temps, formula 5G Wow Seti. It spins off to several videos from its formulas keywords. November 23rd, my thoughts. I was looking up Minkowski spacetime with the OH molecule formula theories and came across this document with interesting diagrams which I believe can be used with the Higgs boson. Electric field lattice crystals, laser beams, proton energies formulas found in the Wow signal data, lines 22. Cross-referencing lines 1 to 27 from Minkowski space and OH molecules, ultra-cold atoms. The keyword Twistor theory comes up. Notice the R sphere where R is a dominant in velocity, alien math equations found in the videos of line 17T4B. We will look at the Twistor theory in this video. Quotes and diagrams are from a blog. R. Penrose, F. Hadrovic, Twistor theory. Sorry, the keyword was Twistor. And we do keyword Twistor theory. Okay, the motivation and one of the initial aims of Twistor theory is to provide an adequate formalism for the union of quantum theory and general relativity. Twistors are essentially complex objects, like wave functions, in quantum mechanics, as well as endowed with holomorphic and algebraic structure sufficient to encode space-time points. In this sense, Twistor space can be considered more primitive than the space-time itself, and indeed provides a background against which space-time could be meaningfully quantized. Stereographic projection. And there's a diagram showing spin 1/2 particle, electron, proton, neutron, and then he's got W up, Z down, equals, I don't know what that means. Riemann sphere, U equals Z over W. In quantum mechanics, a state of an object is described by a vector in Hilbert space. It might help if I put this properly. Sorry. This is a linear superposition of some basis vectors. For example, in the case of an electron for any spin half particle, it is some linear superposition of the spins up and down states. So I'm going to make this a little bit bigger so we can see it. So properties of stereographic projection, and it says angles preserved, circles, general transformation, preserving angles, also circles and orientation. By the way, just on a note, I really love this guy's diagrams, or girls, I'm not sure who did it, but beautiful work. I mean, it's all done in different colors, and it's very interesting to look at, and it's very, I really like the way you've set it up, so I just want to say kudos to you. So angles preserved, circles, general transformation, preserving angles, also circles and orientation. Then there's a calculation there of Mobius trans, relation to relativity, celestial sphere. Lorentz group, non-reflective, is the Mobius group of the Riemann sphere, the symmetry group of the simplest complex manifolds, spinors, twistors. Okay. The two-component vector ZW is called a spinor, or spinor, whatever. The norm of this spinor carries no information. I think it's supposed to be RR. Yeah. Indeed, it is usually set to 1. Only the direction is physically significant, which forces us to consider the projective spin space. In the electron example, spin state is therefore described by a point in CP1, conveniently represented with Riemann's sphere. And then we have a diagram here that says the appearance of a rapidly moving sphere. I'll make that bigger for you so you can see it. RF 1959. And I don't know what that is. Looks like a hot air balloon almost. 3 balloons at the top. No. Lorentz transformation of sphere of vision. And then it says Einstein argument, and it says flat space-time picture. I don't know what this means. And then it says spatial picture. Twistors are spinors for the conformal group of compactified Minkowski space. And then he's got more stuff there. Mathematical stuff on light cone. R6 induced metric. Again, more calculations. Clifford algebra. Spinors, reduced spinors. Talks about complex. Klein correspondence. Complexified, compactified M. Twistor space CP3. And more calculations there. Yeah. Just so you know, I'm just showing you the diagrams here, and then what I do is I went back and did each diagram separately and found out what he had to say about it, just so you know. Because I didn't understand any of this stuff. I just thought, oh, it looks pretty. No. Light ray Z, point Z, Riemann sphere, R, space-time, twistor space, light rays, left-handed IR. He's got all sorts of stuff here. Minkowski space, projected twist. I apologize if a girl did this. Okay, I get it. I just keep saying he. Projected twistor space, PT equals CP3. Z has twistor coordinates. R has space-time coordinates. Incidence. Okay, so you get the idea there. My thoughts. Cross-references diagram of R has space-time Minkowski coordinates with the alien algorithm found in line 17 T4b. Building blocks of the universe math equations for UFO engine velocity and twistor Z coordinates to twistor space. So we'll do a cross-reference later on, hopefully, if I ever get this done. Sorry, I'm on line 22. I got like 27 lines of data. I've been on line 22 for a year and a half now, so it's taken forever to go through. Minkowski space, projected twistor space, CP3, two-spinor rotation, incidence between Z and R. Twistor, complexity. Okay, there's like a bunch of equations there. Best thing to do is actually go to the website where he's got it all posted, and then you guys can go through it if you want to. There's spinor rotation. A twistor represents the momentum, angular momentum structure of a massless particle. Okay, so in that respect, a twistor represents a massless particle, so I'm thinking a neutrino is massless, right? Helicity, where this enables us to interpret twistors that are not null, spinning photons rather than light rays. Shift of origin. Again, more calculations here. Momentum, angular momentum for massless Pitali, quantization, massless field equations. It's amazing what people do, when they do on their blogs. Helicity, assuming these are positive frequency wave functions, twistor functions, home degrees, helicity. I put it down there. Good. Massless field equations, Higgs electric field plus neutrino. Oh, I forgot to finish my bracket. Now shall I get rid of the bracket? I think it's supposed to be a plus sign. Plus Higgs electric field, neutrinos. Superimposed laser particles with cooled plasma, ultra-cold atoms, and mixture formulas, line 22. Wow. Signal data videos, cross-reference lines 1 to 27 for particles, neutrinos, lattice, Higgs electric field. With this data and his calculations to see what we get. Now he talks about massless fields, massless free fields equations, helicity, twistor representation, consistent with twistor quantization, helicity raising, represent twistor acting on FZ. How to get from a twistor wave function to a space-time field. Got more calculations there for you. Strictly, F is a representation of homology. Definition of intersection of overlaps of pairs of open sets. So that's from users.ox.ac.uk. So if you go to this link, you'll be able to look at all these lovely little diagrams that they've worked very hard on. So my thoughts. Line 22, 7B97Z84A, elastic OH atoms, molecule collisions, ultra-cold temps, formula for Equation Wow Seti. And we know it has lots of keyword videos. And the keyword cohomology, Richard Zoza, and applications of sheaf cohomology in twistor theory is going to be in the next video. Thank you for watching.